On this video, we're going to work some problems to prepare for the final. This is view 6 on rational functions. So we start by factoring the sum and difference of two cubes. So we need to know that our form for the difference of two cubes is a minus b times a squared plus ab plus b squared. Notice we have the binomial term has the same sign as our original, and that the powers of a go down and the powers of b go up. And for a cubed plus b cubed, it'll look similar. The binomial will have the same sign and will go down in powers of a, up in powers of b, but we will alternate signs, so it goes plus minus plus. So our first one, x cubed minus 125, we see that 125 is 5 cubed, so our a is played by x and the b is played by 5, so that will be an x minus 5, and then x squared plus 5x plus 25. For our sum of two cubes, our a is now played by 2x, and the b is played by 3. So we will get, for our factorization, we'll get 2x plus 3, then 2x quantity squared is 4x squared, minus 2x times 3 is 6x, and then our 3 squared, which is 9. Okay, now we're going to simplify. This is a multiplication, and so we are going to factor as much as we can. We have a greatest common factor in that first numerator of 3x squared. When we factor that out, we'll be left with an x minus 2. In the denominator, that factors as the difference of two squares, so that will be an x minus 1 and an x plus 1. And the second term, we have a greatest common factor of x squared, which when we factor it out will leave an x plus 1. The denominator we can factor out as 6x, which will leave us with 4 minus x squared, which will factor further as the difference of two squares into 2 minus x, 2 plus x. So we can cancel. The x minus 2 and 2 minus x will cancel, but leave a negative 1. Looks like we can cancel an x plus 1. We can cancel one of those x's. We can cancel the 3 with the 6. And I think that's all we got. So in the top we have our negative x squared, and that's it. So we're going to get a negative x squared on top, and it looks like on the bottom we're going to get a 2, an x minus 1, and a 2 plus x or x plus 2. Either way is okay. And I think that's all we got. Let's try the next one. Now we have a division, so we're going to multiply by the reciprocal. Let's start by factoring. The numerator is going to factor into an x plus 2y and an x plus y. The denominator is the difference of two squares, so that will be an x minus y and an x plus y. I'm going to make this into a multiplication, so the denominator is going to become the numerator. We have a greatest common factor of 4y, and that will leave us with an x minus y. The numerator has a greatest common factor of x squared, which will leave us with an x plus 2y. Now we try to cancel. Looks like our x plus 2y's will cancel. We can cancel an x plus y, an x minus y, and I think that's all. And so we're going to be left with the 4y over x squared as our final simplified answer. Now let's see if we can solve an equation here. So we want to restrict our domain, and we see that x cannot be 2 or negative 2 because that would lead to dividing by 0, which is undefined. We are going to multiply by that least common denominator. So when we multiply that first term, the x minus 2's rather, will cancel, leaving 5 times x plus 2. There's nothing to cancel with the 7, and I'm going to write that as we've multiplied that out as the difference of two squares, x squared minus 4. And here we'll get the minus 10, and that will have to distribute over the x minus 2. So that will be 5x plus 10. That's going to be 7x squared minus 28 minus 10x plus 20. So it looks like the x squared is going to be on the right side. So we'll leave the x squared term there. When we subtract the 5x from the minus 10x, that will be a negative 15x. The negative 28 and 20 is negative 8. We'll subtract another 10 and get to a negative 18. This is going to be a challenge to factor. Yikes. So if we multiply those using our box and diamond, that's a 7 times negative 18, which is a negative 126, and this is a negative 15. So this might take a little doing, but I think we want the bigger one to be negative. I think we can go 6 and 21 to be 126. We want the bigger one to be negative. So now we're going to get in our box, we're going to get our 7x squared, the minus 18, and we can go with a 6x and a negative 21x here. So that means we are going to get greatest common factor, I guess here will be just an x. We'll need a 7x to get 7x squared. We'll need an x times 6 to get 6x. 7 times negative 3 will be negative 21x, and 6 times negative 3 works there. Whew, that was tough. So we have 7x plus 6 times x minus 3 is equal to 0. And so that means 7x plus 6 equals 0, or x minus 3 equals 0. So that means we can get a negative 6/7, or we can get a positive 3. Those both are okay. So those are both going to be solutions. Yikes. Now the next one, we're going to factor every denominator. So that's going to be an x plus 2 and an x plus 3. This is going to be an x plus 2 and an x minus 1. And this is going to be an x plus 3 and an x minus 1. So to restrict our variable, we can't get a negative 2, we can't get a positive 3, we can't get a 1, and I think that accounts for everything. We're going to multiply through by the least common denominator, which is going to be an x plus 2, an x plus 3, and an x minus 1. So on the first one, that first term, the x plus 2 and x plus 3 will cancel, but the x minus 1 will come through. On the second one, just the x plus 3 will survive, and on the third one, it's the x plus 2 that will come through. So we're going to distribute, that's 3x squared minus 3x plus 2x plus 6 is 5x squared plus 10x. Looks like the highest power of x is x squared, and I think that's going to get moved to the right side if we want to keep that positive. So we've got a 2x squared. This will be a negative x, which will add to the other side to be 11x, and then we'll subtract the 6 over, and we're looking at another pretty challenging factoring problem. So if we do our box and diamond again, let's see, we're going to get a negative 12x squared and a positive 11x. So I think we want a positive 12x and a minus 1x. So then going to our box, we've got 2x squared and a negative 6. We can put the 12x in one spot and negative x in the other. So our greatest common factor on the first row is 2x, making that an x. This will become a positive 6. This will become a negative 1. So we're going to get 0 is x plus 6 times 2x minus 1. So that means we'll set each of those equal to 0. So we'll get negative 6, and we'll also get 1/2. Those are all okay. So those are both going to be solutions. Whew, some serious factoring going on there. Now we're going to go to graphing. So we can see when we look at the highest powers of x, that x over negative x is going to act like negative 1. So we're going to get a horizontal asymptote of y equals negative 1. We're going to see that the denominator is 0 when x is 2. That's going to make that be a vertical asymptote. So we've got, there's our y equals negative 1, and here is our x equals 2. We're going to plot a point on either side of the vertical asymptote. So if we put in 3, then 3 minus 1 is 2. 2 minus 3 is negative 1. That's going to give us the point 3 comma negative 2. That's going to put us down here into our kind of quadrant 4 area. We're going to plot a point at positive 1 rather, and x minus 1 is 0. That makes that an easy point to graph. So we're going to now take our limit as x approaches 2. I'm going to come in from the left. If I plug in something like 1.9, the numerator will be positive, and 2 minus 1.9 is a small positive, so that's going to go to positive infinity, and it's going to approach that horizontal asymptote to the left. We'll take the limit as x approaches 2 from the right. So I'm going to plug in like a 2.1. Will be positive in the numerator and negative in the denominator, meaning we're going to go to negative infinity, and there's our graph. On the next one, we're going to factor numerator and denominator. And so there's the numerator, and here is the denominator. We see that we're going to cancel the x minus 2's. That tells us there's a hole at x equals 2. That's the last thing we're going to plug in. We're going to get a horizontal asymptote at y equals 1, and we'll get a vertical asymptote at x equals negative 1. So here's going to be our horizontal asymptote, and here we will put in our vertical asymptote of x equals negative 1. So we're going to plot a point on either side of the vertical asymptote. Nice point to put in might be 0. If we plug in 0, and we're going to look at this kind of reduced form, 0 plus 2 is 2, 0 plus 1 is 1. So we're going to get 0, 2 as a point in our kind of translated quadrant 1. If we plug in, say, negative 2, then negative 2 plus 2 is 0. That makes that easy to evaluate. We're going to take the limit as x approaches negative 1 from the left. So if we plug in say negative 1.1, negative 1.1 plus 2 is a positive, negative 1.1 plus 1 is a small negative. That's going to go to negative infinity. So we're going to drop down there and approach our horizontal asymptote to the left. As we approach negative 1 from the right, we Plug in something like a negative 0.9, we'll get a positive and a small positive, so that will go to positive infinity, and we'll approach our horizontal asymptote. Okay, let's see what else we got. So the next one we see the degree of the numerator is 1 more than the degree of the denominator. That means we're going to have a slant asymptote, so I'm going to long divide. So x times x is x squared, x times negative 2x is a negative 2x. We'll subtract those. X minus a negative 2x is 3x. We'll go plus 3, so that's going to be 3x minus 6. We'll subtract that. 0 minus the negative 6 is a positive 6. And so we're going to see that as x gets huge, the 6 over x minus 2 gets insignificant. So we're going to have a slant asymptote of y equals x plus 3. We can see from the denominator that we're going to get a vertical asymptote at x equals positive 2. So there's our x equals positive 2. And let's see, our slant asymptote, we're going to go 1, 2, 3, and I'm going to go something like that. So we want to pick a point on either side of the vertical asymptote. So let's plug in, say, 3. When we plug in 3, 3 squared is 9, plus 3 is 12, and 3 minus 1 is 1, so 3 is going to be, well, it's going to be way up here. So I'm going to call that 3 comma 12, but you're going to have to use your imagination a little bit. If I plug in 1, 1 plus 1 is 2, 1 minus 2 is negative 1, so that's going to be 1, negative 2. So that is going to be 1, negative 2 is going to be right there. Now we're going to take the limit as x approaches 2 from the left. Now we're looking just at a remainder, 6 over x minus 2. If I plug in like a 1.9, the 6 is always positive. 1.9 minus 2 is a small negative, so we're going to go to negative infinity. So we're going to drop down there, and I don't know exactly where the high point is, but it's going to approach that horizontal asymptote going to the far left. As we approach 2 from the right, again, just looking at the remainder, I'm going to plug in something like 2.1, so that's going to be a small positive, which will make that go to positive infinity, and we'll approach our asymptote going to the right. Kind of jammed in there, but that's the idea. Okay, let's see that we get a horizontal asymptote. We can see that the highest powers of x and their coefficients are going to be 2x squared over x squared, so we're going to get y equals 2. I'm going to factor that denominator into x minus 4, x plus 1. So it looks like we're going to get vertical asymptotes at x equals 4 and x equals negative 1. So let's see, we've got a horizontal asymptote here of y equals 2, and we've got vertical asymptotes at x equals 4, which I'm going to put right there, and also at x equals negative 1. So we're going to need to plot points, 3 different points. So if I put in something like, say, negative 2, then to get the y-coordinate, negative 2 squared is 4. 4 times 2 is 8, so the numerator is 8. I'm going to use the factored form. Negative 2 minus 4 is negative 6. Negative 2 plus 1 is negative 1. Negative 6 times negative 1 is positive 6. So that's going to be a negative 2 and then 1 1/3. So that's going to put us somewhere below our horizontal asymptote. That's a negative 2. So negative 2, negative 1, or positive rather, 1 1/3. And I'm going to plug in 0 because that's easy. 0 over 0, 0 over anything is 0. So that's a nice point to know. And I'm going to plug in positive 5. So when we plug in 5, 5 squared is 25 times 2 is 50. Yikes. 5 minus 4 is 1. 5 plus 1 is 6. So that's 56, which is 25 thirds, which is going to be, let's see, 3 goes into 25. 8 times is 24. So we're talking about 8 and 1/3. So that's going to be somewhere pretty big up here. So I'm just going to kind of arbitrarily keep that on the map and call that 5, 8 and 1/3. So we have a bunch of limits to do. We're going to take the limit as x approaches -1 from the left. And so when we plug in something like -1.1, our numerator is always positive because of the squared term. -1.1 minus 4 is a negative. -1.1 plus 1 is a small negative. So that's going to be positive over a positive is going to go to positive infinity. Oh, this is kind of surprising. So we're going to cross that horizontal asymptote and then approach from below. When we take the limit as x goes to -1 from the right, we're always going to be positive in the numerator. Now we're plugging in a -0.9. So -0.9 minus 4 is still negative, but now -0.9 plus 1 is a small positive. So that's going to get us to a negative infinity. So that thing's going to dive down to approach that from the right. We're going to take the limit as x approaches 4 from the left. So again, always positive in the numerator. Plugging in 3.9 will still give us a negative and positive, so still a negative infinity. I don't know what the high point is, and it doesn't really matter. I'm going to say it's going to do something like that. And then we're going to take the limit as x approaches 4 from the right. So plugging in like a 4.1 is going to make everything positive. And so we're going to go to positive infinity. So we're going to get something that does that. Kind of crazy. I think that's our last one. Let's see. Yep, looks like it. Okay, very good.